our next speaker, you might have seen him throughout the conference here and there. It's me. My name is Arturs Lontons, to those of you who have forgotten about it. I work as a technical support engineer and a trainer, so some of you may have been to my trainings all over the world. And I will talk to you guys about pre-processing. So let's get the slides going and let's begin. Slides, pre-processing. There we go. All right, so why pre-processing? Essentially, let's say we're getting a large chunk of data and we have no way to use it. We need to pre-process it via our external scripts. Maybe we just receive a text chunk, we cannot aggregate it, cannot calculate it. We won't be storing this whole chunk in the database. So that's why we would refer to pre-processing. That's what Zabbix provides. All of these different functions, starting with simple text pre-processing, moving on to CSV pre-processing in 4.4, Prometheus exporters in 4.2, and so on. And we will keep evolving this as we go, and it's been evolved starting from 3.4 quite a bit. And we'll talk about the evolution of it in a moment. So let's take a look historically at what has happened with pre-processing. Where did we begin and where are we now? So before 3.4, it was quite limited. We had custom multipliers, we had numeral system transformations, so Boolean, hex, and so on, and delta calculations, simple changes and speeds per second. And that was it. What if I needed more? Had to use my own scripts, had to write something in maybe Python, PHP, whatever else to pre-process the data, had to refer to that. But nowadays, the situation's a lot better. Our hands are untied. I remember Alexei saying, with great power comes great responsibility. He had that quote in his presentation. So this kind of applies also to pre-processing. So in 3.4, we added the whole pre-processing tab, as you know it. Before that, you would have to configure it in the item selection. Now you can do it in the pre-processing tab. We added regular expressions. To those of you who are familiar with them, you could use them starting from 3.4, simple trims, and working with XPath and JSON path. Then we evolved even further. We extended pre-processing in 4.2. So for example, in 4.2, you can use JavaScript, which is quite a strong feature, and I will cover that in one of my coming slides. You could use validation rules and throttling to even further improve performance, discard unnecessary data, and validate the data that you currently have. Custom error handling, if you want some custom error display, just for additional human readability, understanding what's going on. And we added pre-processing support by Zabbix proxy, thus removing the performance overhead from the server, reassigning it to the proxy, and untying your hands even further when it comes to scaling up. Then also we added Prometheus Explorer support. Why is that? I will cover in one of my later slides. We will have an example with a Prometheus Explorer pre-processing. Moving on to 4.4, which is completely fresh at this point, we improved even further. Pre-processing of XML data via XPath has been improved. JSON path aggregation and search is now supported. It wasn't supported before. Extended custom error handling, so you can assign custom error handling at some other places that you couldn't do them before. CSV to JSON pre-processing, and pre-processing of WMI, JMX, and ODBC data, because now the data collection returns JSON arrays, and we can pre-process it via JSON path, for example. Maybe some of these things were covered by a colleague of mine in one of the workshops in the morning, so some of you may be already familiar with some of this. Maybe you've had a hands-on experience with it, which is great. So now, we know how historically pre-processing developed and evolved. Now let's cover the many available ways. I will briefly go through the simpler pre-processing methods, and then I will delve deeper into JavaScript pre-processing and pre-processing for Prometheus exporters. So, text pre-processing, quite simple. Retrieve a value by using a regular expression. Have a regular expression in the parameters section over there. And we're just grabbing our value, storing it as a number, transforming it from a text. Then, if we need, we can, for example, trim a value, right trim, left trim, if we want to, and just remove some text, once again, store it as a regular number. Then we can work with structured data. I have a chunk of XML data on the screen over here. And if we're talking XML, I can do some aggregations and calculations. And remember, from 4.4, I can also do that with JSON path. Arithmetic, custom multipliers. I can multiply my data by an X amount, maybe to transform from bytes to bits or bits to bytes. Remember, if I want to do division, I need to use 0 point something. In this example, it's 0.125. That's division. And also, I can use delta calculations. Most of you should probably be familiar with this. For example, network traffic. That would be delta speed per second. Essentially, for simple changes, it's just the previous value minus the current value. And for change per second, we also take into account the time when the data was gathered. Then we move on to 4.2. So remember, I mentioned what we introduced. We'll talk about custom scripts, validation, throttling, and Prometheus. This whole new menu section, available on my left, has been added in 4.2, so quite a bit. So JavaScript. JavaScript implementation in Zabbix is done via duct tape. Maybe some of you JavaScript gurus are already familiar with that, so you'll feel quite at home. With JavaScript, we can perform a lot of new things. Essentially, you are limited by your imagination and your scripting skills. So first off, data transformations, data aggregations, data filtering can be done by JavaScript, and logical expressions. We will have an example with some data transformations going on via JavaScript. And remember, all of this is done internally by Zabbix. No need to use external scripts. No need to write anything externally from Zabbix. That's why we are trying to implement more and more pre-processing rules. So you guys have all of this power available within Zabbix instead of having to write some custom scripts on your own without the use of Zabbix. So centralize it. So over here, I'm using disk stats. I'm getting this here value from disk stats. And I can't really do much with it. This value is what I'm getting, and I cannot do really much with it without using JSON. So once I specify my JSON script, which will split my disk stats and transform it into JSON, I can actually use LLD, use pre-processing, use JSON path, and create my items from the disk stats that I'm getting, and create items via LLD for that. So that's where I could use JavaScript, just some custom transformations. And over here, this is a real-life example that I did. I actually had my items created with the corresponding metrics via that JavaScript. It's actually working. If you want to plug it in your environment and mess around with it, you can do that. These slides should be available to you after the presentations. So you can just take a look at this script. If you ask me personally, I can just provide it to you in a text instead of having to write it down from an image. And you can plug it in and see how that works with disk stats. So validation rules. Why? Because we need some custom logic. We receive data and we need to validate it. Let's say maybe we're getting temperature data, and when there is an error on the sensor, we receive some out-of-range data that we need to discard or maybe display an error message in case if we get it. So some advanced logic has been introduced in 4.4. We can check if the value is in range. We can check if value matches a regular expression or if it does not match a regular expression. We can check for errors in JSON or XML, or just check for error messages by using Regex. And if our pre-processing fails, we can display a custom error message or a custom behavior. We can discard the value completely. We can set the value to say -1, which in all cases would mean that there is something wrong with our data, or some other value, arbitrary, that we can define. Or we can set a custom error message, just something human readable, say instead of data being out of range and us getting some error message that's produced by Zabbix, we can set it to a human readable, hey, temperature's out of range, something unexpected has happened, please take a look at our sensors. So over here, I have an example with discarding the value outside of the defined range. So if I'm getting the value outside of -100 to 100, I will discard it. It will not be stored in the database. We'll just completely throw it out. Or over here, I am using a match regular expression. I'm looking for up-down in my values. And if I receive something else, some different service status that I'm not expecting at all, I will set the value to unknown. Thus, more explicitly, being able to react to it, say in case if the value is unknown, I want to fire a trigger and notify myself that, yeah, hey, something's wrong with the service. And I can also check for an application level error located at a specific JSON path or XPath. So over here, I have this example. It's a small chunk of JSON, and I'm checking for this error message field. If it contains data, I will display this error message. I will check for it. If it's not there, that means everything's OK. Same with XPath, and same can be done with a regular expression. So next up, we also introduced throttling. Hopefully, some of you guys have already used it. It's quite a strong functionality when it comes to performance, when it comes to saving database space. Essentially, when we are performing high-intensity service monitoring, this very much applies to industrial hardware. Over here, for example, we're gathering data every 2 seconds, and God forbid we're gathering it in text without pre-processing it and turning it into numbers. And we are storing it all in database. With discarding repeating values, we can just ignore those repeating ups and downs and just store the value when it changes during the changes. Or we can also define a heartbeat. So the data is stored, it's discarded by default and stored on the heartbeat frequency, say every 30 seconds. So over here, I have some very basic examples, essentially same services up downs, only I've transformed them into numbers because I'm not going to store text in my database, gather it every 2 seconds. That's just not going to happen. I don't want it. So before throttling, I will be storing all of these zeros and ones. I don't really need them, but that's the way it was before 4.2. I was storing them. With throttling in 4.2, I'm discarding repeated values, so that saves me a lot of space. And if I want for my no data triggers to not fire because maybe I've been discarding data for the past 30 minutes because the service has been up, that's where I enable heartbeat. That kind of helps us dealing with no data because we are still storing the data, say, every 30 seconds. It's still there, even if it's repeating, and thus we can kind of circumvent the issue of no data firing in case of we've been discarding the data for 30 minutes, hours, and so on. So quite strong. This works with everything. This works with text files. This works with text data. This works with numbers. Say if we're gathering a lot of text from log files and it's repeating text, service status up, something, something. We can use this to discard all of that repeating data and just store it on heartbeats or during changes. Next up, we are also supporting Prometheus exporters nowadays, starting from 4.2. Quite a strong functionality. Another really strong one. Has an unimaginable amount of use cases. Hopefully, some of you have already dabbled with Prometheus exporters, and you know how you can obtain data with that. Essentially, why Prometheus exporters? Because it has a lot of custom integrations, either official ones or community provided ones, that expose the metrics of different systems. So starting from databases, web servers, issue trackers, etc. A lot of them. You can use Prometheus exporter to expose the metrics of these systems. But what if I still want to use Zabbix? I don't want to use Prometheus exporter without using Zabbix and just have a separate system with Prometheus. You can use Prometheus exporter data with Zabbix Prometheus exporter preprocessing rule and push that data into Zabbix. So how would we do that? We would use Prometheus pattern preprocessing rule. First off, we would create a master HTTP item. We would point it towards our Prometheus agent, gather all of that data via the HTTP item. Then we would create dependent items, Prometheus pattern dependent items, and retrieve the specific metric over here. We can either receive a specific metric via Prometheus pattern or a value of a label. But even more elegant is the fact that we can use Prometheus with LLD. We transform Prometheus to JSON, and then we use LLD. So over here below, I have an example. I have a Prometheus to JSON preprocessing rule. And what I'm grabbing is I'm grabbing all of the time spent on a specific CPU node in a specific mode for all modes for all of the CPUs. So in the, let's see, laser over here. Where is it? I'm not seeing it. OK, never mind. In the CPU and mode section, I can define either to grab the data for specific CPUs or for specific modes. Currently, I'm grabbing it for all of the CPUs and all of the modes. So I'll be getting all of the data. This is the JSON that I'm actually retrieving and I'm working with. I will transform the CPU and mode into macros, low-level discovery macros, CPU number and mode, and I will point them towards the specific JSON path elements. So CPU and mode. And I'll also use the help field available to me in JSON provided by Prometheus just to populate the description field. So I have it there. So once I have my low-level discovery rule, I've made sure that I'm getting my low-level discovery macros. I've made sure that I'm getting all of the JSON that I need. I can define my item prototypes with Prometheus pattern preprocessing steps, and then plug those macros in CPU num and mode in the specific CPU and mode attributes. So they'll be automatically discovered, all of these CPUs and all of the modes. And I'll also populate the description field with the help section from Prometheus Explorers. Over here, I can see the result. It's actually populated. And voila, all of my CPUs for all of my modes have been discovered. They're over there on the screen. From my Prometheus agent, that's the default Prometheus agent. You can once again do it yourselves. Just set it up. It's easy. It takes around 5 minutes. And just go by my presentation or maybe the workshop that you had before and see how that works. And remember, there are a lot of custom Prometheus Explorers that you can integrate that way for databases, web servers, help desk systems, etc., etc. Or if you're feeling really handy, you can write your own Prometheus Explorer to expose the data of your systems and then monitor them via Zabbix, store them in a centralized way within Zabbix. And these are the values, the time spent in a specific mode that I'm obtaining over here. As you can see, it's all working. It was all done live on a real virtual machine. So regarding the preprocessing itself, just to clear this up, before version 4.2, we were obtaining raw data if we were using proxies. Proxies were getting raw data, compressing it, and sending it to the server where the data was preprocessed and then stored in the database. Starting from version 4.2, proxies are doing the preprocessing. Remember that. Don't get confused by it. This has a great performance benefit. You can scale up immensely now that this task has been removed, kind of this overhead has been removed from the server and moved to the proxies. This enables scaling up to insane amounts. So now let's dive a little bit deeper. Let's take a look under the hood. What's actually happening? How does Zabbix treat preprocessing when it comes to internal processes of Zabbix? How does it work around that? So let's take a look at preprocessing workflow. First off, I can see that I have preprocessing manager on the screen. This is a process that was introduced way back in 3.4 when we kind of started taking a serious look at preprocessing. So we get the value, and preprocessing manager we pass it to the manager, and it stores it in a queue. It's a first in, first out queue. Once the value is stored in the queue, we then take a look at our preprocessing workers. We can define them in the server config file, actually. We take a look, the manager takes a look if there are any free preprocessing workers. And if there are, we assign all of the preprocessing tasks to that specific preprocessing worker so it does the preprocessing. Once it has executed all of the tasks, we pass it back to the manager, store it back in the queue, see that, hey, there's no more preprocessing to be done. We can transform the data to our specified data type, so number, string, float, so on, and then we store it in the database if everything's been successful. So that's essentially the queue, that's not the queue, but the workflow that's happening under the hood. We have a preprocessing manager, we have preprocessing workers, and the amount of workers is flexible. It's up to you to define it on the server itself, in the server config. So let's cover the manager and the worker. Manager was added in version 3.4. What it does, remember, it enqueues the items in preprocessing queue, assigns the tasks to the workers, and flushes the preprocessed values from the queue to the history cache to the database. So for preprocessing workers, we have start preprocessors parameter in our server config. That's where we define preprocessing workers. How many? There is no perfect answer for that. That very much depends. How complex is our preprocessing in our environment? Is it just a single step trim? Or is it a multi-step JSON path working with Prometheus agents, transforming them that way, then executing some JavaScript and so on. So the more complex it is, the more the amount of preprocessing workers you will need to have. Always keep an eye out on your performance on your preprocessing workers. And of course, always the data gathering processes directly influence the performance impact and the amount of pre-processing workers that you will also need. So not just pre-processing related issues, but also the data gathering itself. So let's recap. What we can do with pre-processing. We can automate. Remember, that's the main idea. We can use master items for, say, Prometheus exporters with LLD to gather all of our metrics, automatically create items from item prototypes based on those. We can customize. We can define different data validation rules. We can define custom behaviors with advanced pre-processing rules, custom error messages. We can discard the data, check if it's in range, and so on. So we can customize a lot of our data, customize how our data is processed and how the error messages are displayed and how the behavior of Zabbix with the data, how that works. Then remember, nowadays we can also use pre-processing to improve our performance, especially with throttling. So feel free to set up that 4.2 in your test environment, or maybe if you're feeling very adventurous in your production environment. Because it's not long-term support, it's standard version. But if you're feeling up to it, plug it in there, set up throttling, and see how you are saving some database space, saving some performance overhead, removing it completely with throttling. And of course, in 4.2, the pre-processing on proxies. Feel free to scale up, guys. And of course, last but not least, data transformations. Remember the JavaScript. We can use that to transform data in any way that we want. Your imagination and JavaScript knowledge is the limit. And of course, with that, we can enable data aggregation and calculation via pre-processing. So this is essentially the 4 pillars where we can use pre-processing and why we should use it. And that's it for me. Thank you, guys. Hopefully, this was of use to you. And have fun pre-processing in 4.2 and 4.4. Thank you.